Uh, Hi, myself Rohit and my friend Pratik. Together we will be demonstrating our computer vision course project. So our project is face recognition. So in this project, we have tried different pre-deep learning methods. The methods are local binary pattern, bag of visual words, and the eigen faces and the Fisher faces. And we have used three data sets. Two of the data sets are the public data sets, and one data set is our own collected data set. So we have implemented these methods and compared these methods in terms of accuracy, precision, recall, and FN score. So now I'll be showing the eigenphase method code. So this is the code. So in this code, first I'm loading the dataset and splitting the dataset into train and test. And then this phase is a technique for face recognition that uses PCA to reduce the dimensionality. And then we represent them as a linear combination of eigenfaces. So like these are the results of the sample from our dataset, and these are the eigenfaces. These are also called as the ghost faces. So this is the test image and this is the prediction. Like you can see, this is the best match, that is the correct prediction. So in this fashion, all the predictions are shown here. So these are the results, and then the accuracy for this dataset is 95%, and then precision, recall, and FL score can be seen on the screen. These are the values. So this is for the AT&T dataset. Similarly, we have done for the ORL dataset and for the our own collected dataset. These are the results for our own collected dataset. Now Pratik will be explaining the next method. So Pratik, over to you.
Yes, as Rohit has explained the eigenphase method, which use only PCA, and that's why it's not only maximize the scatter between the classes, but it also maximize the within the classes also. So that's why we have used another method, which is called a Fisher phase method, that basically maximize uh, the ratio of the class spectrum matrix to the within the class spectrum matrix, so that we can minimize the within the class scatter, and that will help to distinguish the class by the closest phase, and that will perform well comparatively to the our earlier method. So I have used ORL dataset, and here I have loaded this dataset, and some images I have printed here. Then I have split the data into 10 and rest. And finally, I implement this method. First of all, the PCA is implemented, and then after the PCA, this is LDA, which is the implemented for basically maximizing the class scatter matrix and minimize the within the class scatter matrix. So I have computed the class means for calculating the within class scatter and between the class scatter. After applying it, I have computed the Fisher faces. Basically, this is the training images which are project on the subspace that maximize the class spectrum. So once we get this train Fishers, basically I have shown some images of these Fisher faces. These are the intermediate images which are used for classifying. Here the original images, and here are the Fisher faces. So now, I have predicted the wipe rate for the testing images, and the for the entire data set I do the same. And finally I print the accuracy for this data set, which is 96%, and we can see that this accuracy is more than the our previous one. Similarly, this particular method is also implemented the remaining two data sets also. And further, the third one method is local binary pattern method, which I have implemented on ORL datasets, remaining two datasets also. So this method is basically texture descriptor that encodes the local texture pattern in the image, and this for this particular implementing for this particular method, I have used CV2 face dot face LBPH face recognizer that used for train or testing the our data set. And in this particular method, we need to divide the entire image into the regions and calculate the LBP code, which gives us the 8-bit binary code, and create a histogram. When we concurrent on histogram, we will create a feature vector, and that feature vector helps to classifying the training data. Uh, use for classifying the testing data too, and accuracy is printed for testing data here, which is 98%, is slightly more than the our previous method. So these two methods we have implemented. Further, the another method, which is bag of visual words, will explain by Rohit. So Rohit, please explain that method.
Yeah, so now I will be showing the bag of visual words method. Here is the code. So bag of visual methods is actually taken. This concept is taken from bag of words in NLP, and in this technique, here we use image features as words. So here what we do is we first extract features using shift. Then we use a clustering algorithm like the k-means algorithm to get the central points. Now these central points are our visual words. And then we use histogram for each image. Uh, and then we uh, use and classifier like the SVM. So like you can see here in the code, I have used the SVM classifier. So initially in the code, I'm loading all the data and then splitting it into train and test, and then uh, using the shift detector to extract the features, and then uh, using a k-means algorithm for finding the visual words. Once I have that, we can what we did here is we created a histogram for each image, that is for both the test and train image, and then we train the SVM classifier and then do the prediction. So like here you can see this is one test image. This is the test image from the data set, and this is the shift key points for this test image, which are highlighted in the green. So once we get these, we apply the k-means algorithm, then we have the visual words, and then we create the histogram. So these are the results. So for this I have calculated the accuracy, precision and recall, and like you can see for this data set I have got 100% accuracy. So for both the data sets, AT&T and ORL data set, the accuracy using this method is 100%. And when we applied this on our own collected data set, uh, we got an accuracy of 65%. So here there is one limitation is in our data set is due to the variation in facial expression and the different pose of the face. uh, this method is not robust to this kind of variation. So here we are getting less accuracy. So this is about the method back of visual words. So now Pratik, over to you.
Yeah. So in summary, we would like to say that we have applied face recognition method on the three data sets, as we can see in the table. And for the corresponding methods, I have shown the percentage accuracy here, and we can observe that the accuracy varies from method to method. And for the Fisher face method, accuracy is higher than the eigenface, and for the local binary pattern, it is higher than the Fisher face. And lastly, we have used bag of visual words, which are giving very good accuracy, but it is slightly decreasing because of the variation in the uh, because of the feature variation or expression variations in the self-collected data sets. So this is our purpose to doing this project. Lastly, I would like to show you our GitHub repo. Here we have included all Python notebooks for the code, including the README file. Okay, thank you.